Okay, welcome to the deep dive. We're jumping into some really interesting stuff today, looking at a core piece of manufacturing blending.
Yeah, specifically the market for free fall blenders.
Exactly, and maybe we should clarify, these aren't, the blenders you have in your kitchen.
No, definitely not. These are industrial scale precision machines, really critical in sectors like pharmaceuticals, food processing, chemicals, basically anywhere powders or granules need perfect mixing.
For consistency, quality control, all that.
Precisely, they're fundamental equipment.
So the information we're digging into today, it comes from excerpts of a report, right?
That's right. It's the Global Free Fall Blender Market Forecast to 2033 from Cognitive Market Research.
Okay. And our mission here is to kind of unpack what those numbers really mean. We want to get a sense of the global picture, future projections.
Look at the regional differences because they do vary quite a bit, and importantly, understand why. What forces are actually driving the demand for these machines?
Yeah, finding the story behind the stats. So let's start with that big picture, the global market. What are the headline numbers?
Okay, so back in 2021, the report puts the global market at $290.1 million.
290.1 million.
Okay.
And looking ahead,
It sees some pretty solid near-term growth. The projection for 2025 is $358 million.
right, a decent jump in just a few years. And the longer-term view out to 2033.
That's where it gets quite significant. The estimate is $545.3 million by 2033.
Wow, okay, so nearly doubling from that 2021 starting point.
Pretty much. And that works out to an overall compound annual growth rate, a CAGR, of 5.4% globally over the forecast period.
5.4% global average. But you
Yeah.
mentioned regional variation earlier.
Exactly. That 5.4% is, well, it's an average. Some regions are pulling that number up. Others might be a bit slower. It's built from diverse trends.
Makes sense. So let's break it down. Where should we start? North America.
Yeah, let's do North America. It's a major market. Started at $110.5 million in 2021.
Okay. And the
Yeah.
forecast.
Projected to hit $132.5 million by 2025, and then landing around $188.7 million by 2033.
So still growing steadily, $188.7 million. But what's the CGR there? Is it above or below that global average?
It's actually slightly below. The report states North America's CAGR is 4.5%.
4.5%. So solid, but maybe hinting at a more, mature market.
That's often the case, yeah. Growth might be more about upgrades, replacing older systems, maybe adapting to new regulations rather than just sheer expansion like in some other places.
Okay, that tracks. And within North America, the U.S. is the giant, I assume.
Oh, yeah, by far. The U.S. numbers go from $87.2 million in 2021 up to $143.4 million projected for 2033.
$143.4 million. And its growth rate.
That's a steady 4.2% CAGR for the U.S. It's a huge base just continuing to grow.
But the report mentioned something interesting about Canada, didn't it? Smaller but faster.
Yeah, exactly. Canada starts smaller, $13.4 million, but it's projected to basically double to $26.8 million by 2033.
Double. So CAGR must be higher.
It is. Canada comes in at 5.9%, faster than the U.S., suggesting maybe more dynamic growth or, like you said, catching up in certain areas.
Interesting. And Mexico.
Mexico's contributing too, growing from $9.9 million to $18.5 million by 2033. That's a 5.3% growth rate, so pretty robust as well.
Okay, so North America.
Yeah.
Big, established, steady growth overall, may be driven by modernization as much as expansion. Let's cross over to Europe.
Right, Europe, another really significant market, started at $83.5 million in 2021.
And the projection.
Expected to hit $101.7 million by 2025, and then up to $151 million by 2033.
$151 million. And the overall European PAGR. Similar to North America.
A little bit higher, actually. It's 5.1%. Still just under that global average, but slightly stronger than North America's rate.
Okay, 5.1%. And the report breaks down Europe quite a bit. Germany features prominently.
Yes, Germany is definitely one of the heavy hitters. Forecast to grow from $18 million in 2021 to $35.8 million by 2033.
That's a good clip. What's the CAG?
That's a strong 5.9% for Germany, so growing faster than the European average.
But the UK. The report highlighted something specific there, right?
It did. The UK really stands out in the European data. It's flagged as having the highest regional growth rate.
Highest in Europe. Okay, what are the numbers?
It's projected to go from $13.9 million in 2021 up to $29 million by 2033.
29 million. And the growth rate for that?
That works out to a 6.4% CAGR, which is, faster than Germany, faster than the European average, and faster than the global average, too.
Wow, 6.4%. That is significant. Any clues in the report as to why the UK might be accelerating like that?
The report doesn't spell out the country-specific whys in detail, but it links overall growth to things like automation and tighter regulations. So you could infer maybe the UK is seeing a big push to modernize manufacturing, perhaps particularly in key sectors like pharma or food processing that rely heavily on this tech.
That makes sense, connecting it back to those broader drivers. Okay, who else in Europe? France, Italy?
Yep. France is projected to grow from $7.9 million to $14.2 million. Italy, also starting around $7.9 million, is expected to reach $15 million. Both of those have CAGRs above 5%.
Okay, solid growth there too. What about Russia?
Russia shows more moderate growth, from $13.2 million up to $21.6 million, which is a 4.2% CAGR, more in line with the U.S. rate.
Got it. Spain?
Spain grows from $5.8 million to $9.8 million. That's a 4.5% CAGR.
And Luxembourg. I remember seeing that one.
Yeah, much smaller market and slower growth. $1.7 million projected.
This audio was created with Podcastle.ai.
Much smaller market and slower growth. $1.7 million projected to reach $2.4 million, so a 2.8% CAGR.
Okay. And there's the rest of Europe category too.
Right. That segment also shows growth from $7.3 million to $11.3 million, a 3.6% CAGR. So the takeaway for Europe seems to be varied speeds across countries, but overall solid expansion, likely driven by adapting to those evolving standards and automation needs.
Okay, so we've covered the big established markets. Now let's shift focus to the region the report calls out as the real growth engine, Asia Pacific.
Absolutely. This is where the numbers really start to accelerate. Asia Pacific is flagged as the fastest growing region globally.
What does that look like in terms of market size?
It starts at $62.7 million in 2021, projected to hit $82 million by 2025, and then surge to $139 million by 2033.
$139 million. That's a huge jump. The CAGR must be impressive.
It is a very strong 6.8% CAGR for the region overall.
Wow, 6.8%. And what's fueling that? Is this where the industrialization factor really kicks in?
Exactly. The report strongly suggests that. You have major economies building out significant new manufacturing capacity across various sectors. And these new facilities, they need modern blending equipment right from the start, often aiming for high-quality standards immediately.
And within Asia Pacific, China is obviously a huge factor.
Dominant, yeah. China's market is projected to grow from $28.6 million to $64.2 million by 2033.
$64.2 million. And the growth rate?
A robust 6.9% CAGR for China, so slightly above the regional average. It's the biggest market and the fastest region.
But India? The report seemed to single out India for its growth rate, specifically.
Yes, that was a key point. India is projected to grow from $7.8 million to $21.8 million.
Okay, $21.8 million. What's the CAGR on that?
Get this, 8.9%.
8.9%. Wow, that's significantly higher than China's rate.
It really is. It suggests an even faster pace of development or adoption in India, maybe driven by specific industries or government initiatives really pushing demand for this kind of equipment. Explosive growth, really.
That difference is fascinating. What about other key players in the region? Japan, South Korea?
They're substantial markets, too. Japan is expected to reach $19.6 million by 2033, and South Korea around $13.9 million. They definitely add to the region's overall strength.
Okay. And Australia, I think that was mentioned as having a high rate, too.
Yes, Australia stands out as well, growing from $3.4 million to $8.8 million.
And it's huge, yeah.
An 8.2% CAGR for Australia, so another pocket of really rapid growth there.
Very interesting, almost rivaling India's rate. And Southeast Asia.
That segment is also growing steadily, from $2.2 million expected to reach $4.3 million, which is a solid 5.6% CAGR.
Okay, so Asia Pacific is clearly the powerhouse, broad industrialization, but with these hotspots like India and Australia showing really exceptional speed.
Definitely the engine driving that global average up.
Right. Let's move on to South America now. How does the report describe the market there?
Steady and promising growth is the general picture. Brazil leads the way.
Okay, Brazil's numbers.
Projected to increase from $7.4 million in 2021 to $13.1 million by 2033.
13.1 million, and the growth rate.
That's a 6.3% CAGR, which is, quite strong, well above the global average.
Yeah, that's significant growth. What about Argentina?
Argentina actually shows an even slightly faster growth rate, expected to reach $6 million by 2033 with a 6.5% CAGR.
6.5%. Okay, South America is definitely showing momentum. Colombia.
Colombia's a smaller market, but growing. projected to go from $1.9 million to $2.8 million. That's a 5% CAGR.
Okay. And Peru and Chile.
Also on the rise. Peru projected around $2.4 million, Chile $2.3 million by 2033. Both of them have CAGRs noted as being above 5.4%, so above the global average too.
So South America looks like another region where increased industrial activity is clearly driving demand for this core equipment.
Seems that way. Consistent growth across the key countries there.
All right, last region,
Yes.
Middle East and Africa. What's the story there, according to the report?
Modest but consistent growth is how it's characterized.
Modest but consistent. What are the key figures?
Egypt is noted as leading the region. Its revenue is forecast to rise from $1.7 million in 2021 to $3.8 million by 2033.
3.8 million. And the growth rate?
Surprisingly strong, actually, a 5.7% CAGR for Egypt, which puts it above the global average.
Oh, interesting. Okay. Turkey.
Turkey follows, expected to go from $1 million in 2021 to $2.3 million by 2033. That's a 5.2% CAGR, also pretty healthy.
And then there was a rest of Middle East segment. Does that cover Africa too, or is it separate?
The report labels it rest of the Middle East. It doesn't explicitly break out Africa separately in the numbers provided here, just Egypt and Turkey within the broader MEA region. That rest of Middle East segment grows from $2.5 million to $5.5 million.
Okay, and the CAGR for that segment?
5.3%. So again, consistent growth across the board in that region, even if the overall market sizes are smaller compared to, say, Asia or North America.
Right. So we've toured the world, looked at all these different growth rates. How does the report tie it all together? What are those core drivers connecting these regional stories?
Well, we've touched on them, but the report emphasizes two big things: industrialization and automation. You really see that playing out in the high-growth regions like Asia-Pacific and parts of South America, just building more capacity.
Right. Building factories, needing equipment.
Exactly. But the other major driver, which impacts all regions, established and emerging, is the increasing pressure from regulations and market demands.
You mean things like product quality, hygiene standards?
Precisely. The report specifically calls out product customization demands, the need for rigorous quality control, and increasingly stringent hygiene regulations, especially in sensitive industries like pharma and food.
And freefall blenders are critical for meeting those higher standards.
Absolutely. Think about it. In pharmaceuticals, if your blend isn't perfectly uniform, you could have incorrect dosages. That's simply not acceptable.
Yeah, critical failure.
And in food, inconsistent blending affects taste, texture, shelf life, safety. Plus, those hygiene rules mean the equipment itself has to be designed for easy, thorough cleaning and validation. That's a key selling point for modern blenders.
So it's not just about mixing powder anymore. These machines are becoming essential tools for compliance, for quality assurance, for enabling automation.
Exactly. They allow companies everywhere to meet these rising expectations for product quality, efficiency, and safety. That's why you see this consistent demand growth globally, even if the pace varies depending on how quickly a region is industrializing or adopting the latest standards.
It really paints a picture of a market driven by both expansion and sophistication.
That's a good way to put it. It's not just about more blenders, but often about better, more capable blenders meeting tougher requirements.
Okay, so summing up the key takeaway from this report, we're looking at pretty significant global growth for freefall blenders, projected out to 2033.
Yeah, a solid trajectory overall.
But it's not a single story. It's fueled by this mix of rapid industrialization, especially visible in places like Asia-Pacific, and this universal pressure for higher quality, better automation, and stricter compliance everywhere else.
With regions like Asia-Pacific, parts of South America really accelerating, while North America and Europe maintain scale and focus maybe more on upgrading and meeting those advanced requirements.
Right. So based purely on what the report highlights about those increasing demands, customization, quality, hygiene, especially in pharma and food, it does leave you wondering, well, how does the equipment itself need to evolve if those pressures keep intense?
This audio was created with podcastle.ai.
The equipment itself need to evolve? If those pressures keep intensifying, what specific design changes or new functionalities might become even more critical for freefall blenders in the future? What features will manufacturers absolutely need down the line? Something to think about. Welcome along to the Deep Dive.
Great to be here.
Today we're getting into, well, the nuts and bolts of industrial mixing, specifically freefall blenders.
And we've got some excellent source material from cognitive market research to work with.
Right. So our plan today is really to unpack the key dynamics, understand what's pushing demand, maybe what's holding things back a bit.
And where the whole technology is heading. What's shaping the future for these machines?
Okay, let's dive in. The research jumps straight into the drivers. What's making companies go for these blenders? Pharmaceutical seems to be a huge one.
It really is. And the reason why is, well, it's pretty interesting. For things like powders, granules, tablets, capsules, you need mixing that's incredibly gentle.
Gentle.
Yeah, and uniform. Free-fall blenders, they work by tumbling, right? No aggressive internal parts like paddles or ribbons. It's a low-shear process.
Ah, okay, low shear.
Which is just crucial for protecting sensitive active ingredients. You don't want them breaking down during mixing.
Right. Makes perfect sense for pharma, preserving those delicate compounds. What about the food industry? That's another area highlighted.
Absolutely. Similar principles, but maybe different priorities. Hygiene and consistency are paramount in food.
Sure.
The source points to things like spices, powdered drinks, baking mixes.
Lots of powders.
Exactly. You need that perfectly consistent blend every single time, and you need to maintain the particle size, the structure, plus, of course, meeting all those strict food safety standards.
Okay. And I noticed the source also mentioned smaller businesses, SMEs. Why the appeal there?
That's another important angle. For smaller outfits, maybe in chemicals, plastics, cosmetics, it often comes down to simplicity and cost effectiveness.
Easier to run.
Much easier. They're low maintenance, generally simple to operate. No complex internal moving parts to clean or, break. That means less downtime.
So quite economical overall.
Very user-friendly and economical, yes.
Okay, so gentle action, good hygiene, easy operation. Sounds pretty good. But there must be downsides, right? Where do they struggle?
Oh, definitely. The research is quite clear on the restraints. First off, material limitations. It's a big one.
Meaning?
Well, they rely on gravity, things need to tumble freely. So if your material is sticky, cohesive, or even just a bit moist...
The stuff that clumps.
Exactly. Stuff with poor flowability. Getting a good uniform mix is, frankly, very difficult. They just aren't designed for that kind of material.
Okay, gravity needs flow. Got it.
Wow.
What else? Mixing time.
That's the next point. Compared to mixtures that use more force high shear types, these free-fall ones generally take longer.
Longer cycles.
Significantly longer sometimes to get that same level of blending, that homogeneity, especially if you're mixing powders with different sizes or densities.
And that affects production speed.
It impacts your throughput, yeah. So maybe not ideal if you need really high speed, high volume output.
Right, and connecting that to modern manufacturing scalability.
That's the third key restraint mentioned. These are fundamentally batch mixers. You load, mix, unload. Load, mix, unload.
One batch at a time.
Precisely. Trying to integrate that smoothly into a modern, automated, continuous processing line where material flows constantly well, it's complex. It's not really their natural fit.
Okay, so strengths and weaknesses are becoming clear. Now, for the really interesting part, how is this tech adapting? What are the trends pushing things forward?
Well, one major trend is their use in really specialized controlled places. Think aseptic processing, clean rooms.
High purity stuff.
Exactly. Driven a lot by regulations in biotech and sterile pharma. So manufacturers are responding with GMP-compliant designs.
Good manufacturing practice.
Right. Modular units designed specifically for clean room integration and crucially compatible with CIP and SSIP.
Clean in place, sterilize in place. So you can clean and sterilize them right there.
Without taking them apart, yeah. Absolutely vital to prevent contamination in those super sensitive applications.
Makes sense. What else is trending?
Digitalization. Definitely. We're seeing more integration of IoT sensors.
Smart blenders, is that what we're talking about?
Pretty much. Real-time tracking, you can monitor rotation cycles, check how well things are mixing, log safety data.
Oh, for traceability.
Huge for traceability and validation, especially, again, in those regulated industries where you need bulletproof records.
Okay. And lastly, are they all standard or is there tweaking involved?
Oh, lots of tweaking. Customization is really ramping up. Manufacturers are tailoring the designs, changing the bin shape, the geometry, how it discharges.
Why?
To optimize performance for very specific, sometimes tricky materials, maybe a particular pigment for paint or a specific detergent powder, getting it just right for the application.
Gotcha. So let's try and pull this together. Free-fall blenders, they've got this niche based on being simple, hygienic, gentle. Great for free-flowing powders, especially in pharma, food, maybe smaller operations.
That sums it up well. But as the research points out, they do hit walls with sticky materials, they take longer, and they're not natural fits for continuous high-volume lines.
Right, but the tech isn't standing still.
Not at all. It's evolving, getting smarter with digital monitoring, adapting to those high-purity demands with cleanroom designs and CIPSP, and becoming much more specialized through custom builds.
So here's a thought to leave you with, based on that source material.
Yeah.
Given this push towards digital tracking and all this customization, could future freefall blenders actually overcome those big limitations,
Okay.
like with sticky materials or even continuous flow? Could applications that seem unsuitable now suddenly become possible down the line? Something to think about.
This audio was created with Podcastle.ai.